This is the Amp Hour Podcast, released January 21st, 2018. Episode 376. An interview with Richard Ginus. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I am Richard Ginus of TWTG.
Welcome, Richard. How are you doing?
I'm doing great.
Where are you calling in from today?
I am calling from the city of Rotterdam in the Netherlands.
Very cool. So tell me about, what's it like working electronics out in the Netherlands? I have not been, although, as we were talking about just before the show, that may be changing. I need to verify my travel plans.
Okay. Well, the scene is really great, especially for IoT.
Okay.
Innovation is really high on the agenda on most companies in the Netherlands. So all the major companies have something on their agenda that has to do with IoT. So there's a lot of work in this field.
Mm-hmm. And why is there like a cultural reason for that, or just a technology reason, or is it university based? What actually drives that?
We have a couple of technology universities that are pretty active. Mm-hmm. We are well known for solar applications in the solar race in Australia. We also have Philips. Philips is...
I've heard of them, yeah.
Yeah.
Kind of big, yep.
Well, they mostly went into NXP. NXP also has a lot of jobs. And ASML, it's...
lithography.
Yeah.
That's a huge one. Okay.
Yeah.
I didn't know that was there, actually. I know the name, but I guess I didn't know where it was. So, okay. And so what are the universities like there too? Is that a lot of the source of that stuff, or is it more corporate sponsored research?
I think it's a lot of corporate sponsored research. Mm-hmm. Also a little bit of in schools. You already get the IoT stuff in schools. It's mm-hmm. really the connection between business and school is really good. I think.
That's great.
I don't know how it's in other countries, but it's great here.
Okay. Yeah, that's wonderful. Like a lot of internships and stuff as well, or
yeah.
Okay. Yeah, it depends. I think in the States at least, it's a little bit more regional. I definitely chose a school based on the ability to go do internships, or we called them co-ops for like longer periods. But I love that stuff. That's what I'm all about, the experiential learning stuff. So, yeah. I forgot about this. So there was this amazing National Geographic article about Holland and the agricultural stuff. Like it's a really big, tons of sensors around that, but there's this beautifully shot like National Geographic piece about it. Have you seen a lot of agricultural stuff as well?
Yes, actually, we do. We have some projects that have to do with soil measurements. Mm-hmm. So you can imagine measuring minerals and measuring soil moisture. Yeah, that kind of stuff.
Okay. Yeah, it's interesting to me that like you said, solar is a big piece there. I wouldn't have expected that. It doesn't seem like a particularly sunny country. Am I wrong in that, or?
No, it's far from sunny country, but maybe that's the driver. You need to be extra efficient to have some kind of.
Yeah, that's a good point. Yeah. And then I knew about, some of the agricultural stuff, like that was the big tulip thing, right? Isn't that what one of the famous pieces of the Netherlands?
Yeah, I believe so. I don't really get a lot of sense for that myself because mm-hmm. I don't really live in those regions. But okay. We're really famous for our tulips, and you could also use technology to get even more beautiful tulips, of course.
Right. Yeah, that's great. So, what about you? So, what is your school background, and then how'd you kind of get it started into the industry? Because you're relatively young, right?
Yeah. I'm 25, so I just got out of school in relative terms. Mm-hmm. Well, I really liked electronics from a young age. When I was just 3 years old, I was sitting under the desk and beside the computer and looking at circuit boards. Nice. And always have like a feeling that I have to do something with that and I have to explore that further. So I went through a stage of IT and ICT and software development early in the school after high school. What's that?
Yep.
College? Yeah.
Yep.
I did a course that has like a lot of software, a little bit of electronics, a little bit of even business, entrepreneurship. So I'm really broadly taught, and but I always in my internships and all my choices I made, I always reverted back to hardware. So
So say we all. Yep.
Yeah.
I think most people listening here will be like, yeah, okay, yeah, of course you went back, yeah.
Because software's fun, but if it doesn't work and it's someone else's fault because he wrote something wrong, then there's you can get pretty angry. But if you have hardware, then it's almost always either your fault or Mother Nature's fault.
I like that, yeah.
Yeah, and it's pretty hard to blame Mother Nature. So
I curse it every day, though. Come on. I mean, I live in a snowy region, so that helps too.
Yeah.
Okay, that's great. That's great. And as you were explaining some of your background there, I feel like we should, we're about 5 minutes in. We should talk about what we're going to be talking about here today, and then we'll get back to all this stuff. So I had been talking about some LoRa projects, and you had written to me and you said, "Hey, I could talk to you about this," and I'm like, "That's great. I'd love to talk about it." So that's why that was the background between IoT and all this other stuff. So maybe work us up towards, so you get out of school or maybe even working on projects like this in school. You said there's a lot of IoT focused stuff. How did you get to where you are today?
Well, my study also focused a lot on media. So that's like the classic TV, radio, that kind of stuff. So the first electronics things I did were mostly LEDs.
Okay.
But they were also always connected to some kind of studio managing system. So that meant some kind of network. And in the beginning, that was Ethernet. And then when wireless chips became more available to hobbyists, that was also wireless via Wi-Fi. Some kind of you have those transceiver chips that do some FSK, like serial in, serial out kind of stuff.
Right. Like wire replacement, basically, kind of stuff?
Yeah, exactly.
Okay.
But only when I started to work for my previous company, which is a big ICT consulting company, there someone mentioned LoRa, and he mentioned some amazing specs, like 10 kilometers of range on a couple of batteries. Yeah. And then I just said, that's not possible.
Yes, it does. Every time I see the specs, I'm like, okay, well, let's get into this. It doesn't seem realistic. So I'm right there with you.
Yeah. So exploring that further and doing some projects and getting in on the early development on the networks here in the Netherlands, I started using actually my hobby, which is flying RC planes, to explore LoRa.
Okay.
And I put a LoRa radio on the plane. Brought it up.
Like you were distributing like the LoRa signal for other, like you were a hub on the plane, or
no, okay. Just a client, and I used a network from a provider in the Netherlands to connect. But when I got up and I circled around a bit and got down and looked at the laptop for the data, I saw that I hit multiple gateways, you call them. One that was in Antwerp in Belgium. And one is in Utrecht, in the middle of the Netherlands. So that's quite some range. And from that moment on, I was sold on.
Wow! Is that because of the added height? So you got over the horizon line? Is that
yes,
that you would have otherwise?
Yes.
So what were those relative distances then with to Utrecht and what was that in Brussels? You said I don't.
No, Antwerp.
Antwerp. Okay.
From where I was standing to Antwerp was 75 kilometers, and to Utrecht was, I believe, 35 or something.
Okay. So that's kind of crazy. And what were you? So like you were just kind of piping back data at that point, like just.
Just altitude data and temperature data, I believe.
Okay, yeah, that makes sense. Wow. All right. Well, that's a data point there. And you mentioned, well, let's get a little bit further. So you started with this in your hobby, but then you also kind of took it back into the professional side of things. So how's that translated then?
Yeah, I took the equipment from the company I worked with home to play with it over the weekend. Then I discovered this. And when I brought the results back, everybody, of course, was really impressed, and some didn't believe it and spent days looking for the error I made.
That's nice. I mean, I guess it's engineering, right? That's
yeah.
Right.
So also we told some people at the company, which is just a classic software company, and we started to work on some LoRa project over there because there are some clients that would see potential in these kinds of things.
Yeah.
So I worked on a LoRa project used to pipe data back from cyclists, the race cyclists.
Oh yeah, okay.
In Belgium and France, to the team leader car.
Okay, that's a good one. I mean, that's like on the move. It needs to be battery obviously not tethered. No wires going to that. That'd be a lot of wire.
Yeah, and also a very noisy environment.
Sure.
That's why we initially thought LoRa was a good choice.
Okay.
But it's really not. But I can explain that.
Okay. Okay. And then, so what other kind of? So that's obviously like a fast-paced kind of environment. What about, you're also doing stationary type stuff? I'm guessing a lot of sensors here, right? Sensors, battery, micro, and then a LoRa module. Is that kind of the thought?
Yeah.
Okay.
LoRa is actually a really bad choice for the cycling thing because it was a lot of data and it needed to arrive relatively real time.
Got it. Yep.
Which is absolutely not the power of LoRa.
Right. Okay. Okay.
The power of LoRa.
Yeah, I was gonna say, what is a sweet spot then? Because this is kind of, as people look at all these different options. Like I'm in the cellular space, and there's LoRa. That's why I got interested in it as well. There's Wi-Fi. There's Bluetooth. There's all these different things. What about LoRa and similar type of things are worthwhile checking it out for?
Yeah, there are a couple of LP1 technologies, which is a group of technologies where LoRa is in. Most of them are ultra narrowband based, but LoRa isn't.
Okay.
And it's actually a wideband signal.
Okay. Yep.
The data rate, the amount of data you can send is really low. The range is really high, and also the battery life is really good because it doesn't really take a lot of energy.
Yep. Yeah, it's a short burst and then it turns off, and well, like you said, if it's not transmitting a lot as well, that helps, right?
Yeah.
Okay, so someone who's, like I said, got a sensor, got a battery, got a micro, and then has a sleep mode, they might want to take a look at LoRa as well. So what about LoRa? I've like I said, I was doing a little bit of research beforehand, but LoRa is actually a proprietary thing, right?
Yes. LoRa is nothing more than an IP block that describes modulation.
Okay.
And then you're talking about LoRa-Phi. You can also differentiate between LoRa-Phi and LoRa-1.
Okay.
LoRa-1
I say WAN because I'm from Amherst, New York, but yeah, WAN, yeah.
LoRa-WAN or LoRa-1 describes a network architecture.
Okay. That would be like more, so kind of like a higher level and actually talking to multiple devices. Is that kind of the idea?
Yeah. It's almost a carrier grade network. So you can set your own network up with a few gateways and have thousands of devices connected to the same network.
Okay.
And uploading data.
Okay, so what about at your company and in your own work as well? Have you explored some of the other, so it seems like there's a kind of a wide swath of different technologies in here, but I'm not really sure which are just brand names and which were otherwise, right? Because there's it's like Sigfox is one that I've heard a lot as well.
Yeah.
And that seems like a similar technology, but it's definitely proprietary and branded, right? That's like they provide that wide area network.
Sigfox is actually Sigfox. The protocol is open source.
Okay.
But you can only use it with their own worldwide network.
Okay.
So you're locked into the provider, but you have a lot of more choice of implementation on the node side.
Okay. So, there's multiple manufacturers of the nodes. You mean? Is that the idea?
Yeah. You can just use general TI CC 1100 series, for example.
Okay. And then you have to actually buy buy a license or something to use it for that?
No, you can implement your own stack on it, or you can get a stack from Sigfox, and then I believe you have to go through certification from them before you can use their network.
Okay.
And then you have a cost per device per year.
Okay. Oh, okay. So then it's just that's the idea. Is if you're going back through their gateways, that's kind of provided.
Yeah.
That makes sense. Okay. So comparatively, there, if you're going to set up your own LoRaWAN, then you would be able to not pay the gateway price, right? Because you'd be setting up your own gateway, but you'd also have to manage that whole stack as well, right? So it's some kind of network area, right?
Exactly. Yes.
Okay. Interesting. What about then? Have you looked at like the 802.15.4? Is that another one that's on your map?
No, we don't really do a lot with that.
Okay.
We do, however, a lot with narrowband IoT, which is a standard by the 3GPP.
That's right. Yep. Okay. And that's one I've heard a lot more about because that actually was just announced at CES, which I just got back from. T-Mobile is the only provider doing it in the States, and they just announced that they just rolled it out stateswide, and whereas it's I think very popular in Europe.
Yeah.
So there's a lot of carriers over there doing that. So
we already have multiple carriers and covering the whole country. So
okay, yeah, and that one's like lower bandwidth. It's only one direction, right? You can only transmit. You can't.
No, you can. It's two directions.
Oh, okay. Maybe I've got that back. Maybe I'm thinking of a different one then. I thought it was only one way. Okay.
Sigfox has a very limited downlink from the network to the device.
Got it. Okay. Yeah. Okay. And okay. So but there, like you said, lots of carriers over in Europe doing that kind of thing. So that's interesting as well. And I think that that's got coverage, but maybe not as much distance coverage, right? You don't get as much. You only need to go to the tower instead of going to across over the horizon kind of thing.
Yeah. Narrowband IoT has a lot of penetration, which is really interesting. We actually tested it 50 centimeters underground.
Oh, really? Oh, wow. Okay.
Almost 2 foot.
Uh-huh.
And it still works with the cellular tower about a kilometer away, in our case, which I think is really impressive and opens up a lot of new cases that weren't possible before.
That is interesting. I hadn't really thought about that whole getting through stuff thing. But again, when I was at CES, I saw a booth that was interesting. What was the one? There was another one I saw where it was they were specifically made to go through walls and stuff like that. It was a 900 megahertz type thing, but it was like the algorithm was there to ensure that you actually got through the walls.
Yeah.
Oh, SurePhi, it's called SURE-Phi. So.
I never heard of it, but I guess it's a ultra narrowband technology. So you put a lot of energy in a really tiny bit of spectrum.
Yep.
And then you can get further through things.
Yep. Okay. Yeah. So I asked about the 802.15.4 because that's actually, if people remember Akiba being on the show in the past, that's actually what Akiba uses for the rice farming stuff as well. So it's similar, like distance wise and battery wise, but it's a open standard, I think.
Yeah. I think so too. But it also just defines point-to-point things, or maybe mesh.
Right. Yes, I believe so. Right.
Which is not as interesting for a lot of customers. We notice.
Okay. Yeah, and that is a good point too. So maybe we can walk through the different layers as well, because some of this is talking about the hardware, right? So like, what frequency is the radio transmitting at? Some of it then is like a firmware layer, and then there's different levels of abstraction up the stack, right? That's kind of the idea, as far as I understand it. Maybe you can help me out there. It's like LoRa's using different frequencies, right?
You can apply LoRa on a lot of frequencies. Yes.
Okay.
It's usually used on the ISM bands.
Okay.
Down from 160 megahertz in the US, I guess, to 315, 433 megahertz, 868 megahertz, and 915 megahertz.
Yep.
And it depends on where you are, which bands you are allowed to use, and with what rules you are allowed to use them. Okay,
like you mean operating as a user? You mean, or how much power or what?
Both. For the 868 bands, for example, in the EU, we have a rule that you can only send 1% of the time.
Oh, interesting. Okay.
Which is 36 seconds an hour. And if you send more than that, you're actually illegal.
Really? Okay. And is that is sorry, I don't actually know. Is there a governing board? Is it also called the FCC there, or is it called something else?
It's called something else. I believe the Dutch thing is called Agentschap Telecom.
Okay.
I already met them. They're really great guys.
Okay. I was gonna say, was it a good meeting or a bad meeting?
It was a bad meeting at home, so just some out of hand Wi-Fi networks.
Got it. You didn't get arrested though. Sorry.
No. just a warning.
Mm-hmm. All right, that's great. That's a good thing. Okay, so only 1% of the time though. So that's of all devices that operate in the 868 band.
Yes.
Interesting.
There are some certain subbands, but it's a really tiny sliver of spectrum where you can have 10%. But that's just one band, so it's also not very much.
Okay, yeah, that's crazy. But I mean, well, again, at the data rates we're talking about, like you're not piping video. That we should make that clear for people listening.
Yeah,
it's not like you're doing audio, video, or anything like that. It's like the temperature is 4, right?
Yes.
So yeah, I mean, MQTT type data and getting that out there, right?
Yeah, when you're sending, the data rate will be like between 0.3 kilobytes per second to about 11 kilobytes per second.
Okay.
But that's only a part of the time, so it's really not a lot of data.
And have you found that you run into that and you say, oh, I can't work with this? I mean, or maybe that cycling example is a good one. So like, what were you trying to send versus, where did you start running into limits?
Yeah, we were just trying to constantly update the car with actual data of pedaling power, but we just didn't really know about the 1% rule yet, because that's
right. Right. Well, that's what you learn in situ, right?
yeah, of course. And so that's, we actually ignored the rule. In the early days, there were some modules that were not restricted. The modules you buy now have a built-in library that restricts you from sending after you go over the limit.
Mm-hmm. Okay. And so you were just trying. So you were okay. So maybe that helps with the stack discussion too. So in that case, were you implementing your own LoRa stack? Is that the right phrase?
Yes. Yeah. Well, I of course got it from the GitHub from IBM.
Okay.
And then you can implement it on an ARM chip.
Oh, really? Like that level of like what kind of processing was necessary? Was it like an M3, M4, something bigger?
I believe it was an M0 actually.
Oh, okay. All right. So low power, low processing.
Yeah,
that's good.
The thing is, you do need a chip from Semtech, which is the owner of the LoRa IP.
Okay.
And that's an SPI controlled chip that does the radio part and the low level communication, and then you need to run some library to get the data out.
So that's from Semtech. What is there like a family name there of what it's called?
You have different families of chips you can use for LoRa. There are specific gateway chips, and there are node chips. The node chips start with SX1270X. Okay.
And that's the node chips. Okay.
Yeah. And the gateway has some specific chips where they divide the front end of the radio and the baseband processor into different chips.
Okay.
But gateways have a lot more sensitivity, and they can do 8 bands at the same time, or 8 channels.
Okay.
So they can send a lot more, and always listen on one channel for join requests, for example.
Okay. Now that's okay. Yeah, definitely gonna get into that. So the idea is that Semtech owns this, so they created this. I see a little R, so all rights reserved on LoRa. So that's interesting. So when people say LoRa, though, that means it's going through a Semtech chip.
Yes.
Okay.
There's one other way I currently know, and that is GR LoRa.
Okay.
And that's someone reverse engineered LoRa protocol and made a GNU radio plugin
interesting. Okay.
to encode and decode LoRa packages.
Oh, interesting. Yeah, the concurrence of me getting some LoRa modules is also concurrent with me getting a hack RF, because I was hoping to kind of see what I was doing and maybe decode stuff live and really just troubleshoot my crap that doesn't work. You know, that's so what are you usually doing when you're troubleshooting? Are you using just spectrum analyzers and similar, or how are you dealing with it?
I am actually also using a hack RF.
Oh, really?
So,
okay.
Yeah, it's ideal, but I usually don't go further than the waterfall diagram.
Okay.
And just see if is a message sent on a particular channel.
Got it. Okay. So it's pretty much using it like a spectrum analyzer, but with waterfall, like you're saying.
Yeah.
That is super useful. And you had actually sent me a picture of this, so what the actually looks like as you're moving through it. And we'll post it, but maybe you could try and give us a word picture here as well.
Yeah, well, the modulation of LoRa uses a chirp modulation, chirp spread spectrum. And that's a way to reduce influence from multipath and that kind of stuff, which makes it on a waterfall look like zigzags across the screen.
Right. And that's because the chirp, and maybe you could explain the chirp spread spectrum as well. I can never say that right.
Yeah, so information is encoded in chirps, which is just moving up and down in frequency in the spectrum in time. And the direction of the chirp simply says it's a 1 or a 0. It's a little bit more complicated, but
okay. No, that's interesting. That I actually didn't realize it was the directionality thing. So that's the idea, is that basically if it's going up or going down, for example, up is a 1, down is 0. That's the idea.
Yeah. For example, okay. It's a little bit hard to explain through speech, but
right. Well, we'll definitely, like I said, we'll share pictures for sure. But if people have seen chirps on like that's effectively actually what a spectrum analyzer is usually doing, right? Is sweeping through different frequencies, and then that allows you to see different things as you go through the frequencies, right? So, or network analyzers do that as well. People think about inject a 10 hertz to 1 megahertz signal, you'll see how a circuit responds over time. That's kind of the idea. So you mentioned it reduces multipath, though. So could you maybe explain that a little bit?
Yeah, in a lot of situations where you use low power wide area networks are urban areas. For example, detecting if a parking space is empty or not. So there are a lot of echoes essentially in the signal. It's being transmitted, it's echoing of buildings, and it all arrives at the receiver at different times and at different amplitudes. And the spread spectrum chirp modulation helps to get the right signal out. So it makes the signal to noise ratio better.
Okay. And so would the idea here be that so you have the main signal being sent, you have one reflecting off a building, you have one that reflects off a building 2 blocks down the road. Is the idea that basically because of this, you'll see the strongest signal as it shifts through time, or what is it about the shifting that helps?
I don't know really in fine detail, but I believe it's easier to track the signal because it should be it's at some place in some time, and then you can predict a bit over where it will be a little time later.
Okay. Yeah, that's good. Okay. So and then it is spread spectrum as well, and so is that just because it hops between different bands within different channels within the band? Is that idea?
No, the spread spectrum part is just the chirp. So it starts at a certain frequency and ends at another frequency.
Okay. So didn't you mention channels though, or something like that within the 868?
Yeah, that's true. The 868 part of the spectrum that you can use license free has room for a few channels.
Okay.
Because LoRa uses channels that have a certain bandwidth. You can actually set the bandwidth, but the most common one is 125 kilohertz.
Okay.
So you divide the 868 band in 125 kilohertz channels. And on each channel, you can use the 1% rule.
Oh, okay. And how many total channels fit in the 868 then? Is it?
I believe it's 8.
Oh, okay.
But don't quote me on that.
No, that's fine. Yeah, we'll put that on people to actually do that. I guess that makes sense. That'd be like 1 megahertz total, right? Yeah. So, okay, that's great. So that does open up though, reducing interference and all that other stuff. Because I imagine if you have two sensors right next to each other and they were on the same channel, you'd be kind of just guessing, you'd hoping that they don't transmit at the same 1% interval, right? That would be problematic. And then you would start to lose data because of interference and stuff, right?
Yes, that's true.
Okay. So what about that then? So like, say you now you have 1,000 modules out in the field, right? Or within an area for gateway or whatever. What did you call it? You called it there's the node and the gateway, or is there something else?
Well, 1,000 nodes in reach of one gateway is it's honestly is a bit much.
Okay. Okay, that's good to know. Yeah.
But you want to design your application in a way that they don't inherently send at the same time.
Okay.
Because that will you will get in trouble basically.
Okay.
Because there are 8 channels, there are 8 devices that can send at the same time. Nodes can check if there is free airspace available, and then only send if there is some free space.
Okay. And what's the usual like transmit time then, all told? Like, so you said like 36 seconds, but would a device it wouldn't actually use all 36 seconds, right?
No, not in one message. Messages can take quite long. I have seen messages that are almost a second when you fill the packet full of data and use the lowest spreading factor, which is also something we can talk about.
Okay.
But there are also messages that are like a millisecond or so in airtime.
Okay. All right, that's good. Yeah. So what about then? Okay, so now, like I said, like the 1,000, or you said the 1,000 is probably unrealistic, but I imagine over time as this gets more popular, there will be more that are not necessarily like. So if I set up, 10 sensors in a part of a city, that's fine. But then there could very well be other sensors in the city that are also crowding it out. So what happens in that case? Is there brokering, or how does that all work?
Well, that's actually some people say that it's a big problem. It will be a problem sometime in the future.
Okay.
There will be coexistence problems. If everybody would use LoRa, we would get there pretty quickly because LoRa has a wideband.
Okay.
So there is a little bit less space for other people to send stuff.
Interesting. Yeah.
So I hope there will be a lot more spectrum opened up to these kinds of technologies.
So Richard says, don't step on his LoRa, even though he's on here. Yeah, don't. If you're in Rotterdam, stay away.
Well, we actually never had any problems with that yet.
Okay.
With overcrowded LoRa stuff. I have been at some meetings and trainings where the air was really busy. But it still all kind of works.
Okay.
I don't know this for sure, but I believe even if signals partly overlap, that receivers can pick that out.
Yeah, right. And so and maybe this is a good thing to ask about too. So you said, like this can handle lots of stuff, but also far away. So then, what about so maybe going back to your RC plane example, right? So you now have a device that's transmitting temperature from, a kilometer up? I don't know how RC planes fly. 100 meters up.
I shouldn't say it's more than 120 meters.
Okay, so 100 meters up.
Yeah.
I guess above that, the RC plane probably would start to drift. Okay, so 100 meters up, but it's 100 meters up, still pretty good distance.
Yes.
Okay, secretly in my head, I was trying to do the conversion, stupid American, imperial units. So 100 meters up, and it's transmitting, but now there's someone getting a packet there's someone in where did you say it was? Antwerp, right? So someone in Antwerp, you saw a tower in Antwerp,
Yes.
but someone was also transmitting in Antwerp at that time, right?
Yes.
So what happens then? So if in the instance that it was absolutely like dead on, the exact same frequencies, the exact same channels, the exact same time, would a receiver be able to pick it up in Antwerp, or we would just never have seen it?
I think what would happen is that the receiver in Antwerp would pick up the guy that is in Antwerp.
Okay.
And leave my message, as nothing.
Okay. All right.
Noise.
So it just would have gotten flooded out by the higher power signal close by.
Yes.
Okay. So it's safe to assume that the one that hit the tower in Antwerp was, it was open at that time, right? It obviously talked to that tower. Yeah.
Yeah, it's really early days, so the spectrum was really not used a lot.
Okay. It's interesting though. So again, going back to that example of there's a guy in Antwerp that flooded your signal out. In that case, would it just your signal would look like background noise to that signal? Is that kind of the idea? And then the gateway is just drawing that higher power signal out of the noise that you're contributing?
Yes. It could also very well be if the signal was still good enough that it would pick up both signals.
Okay.
If there's enough interference, then it won't do anything.
Mm-hmm.
But if the strongest signal, of course, is very much easier to decode than the weaker signal.
Right. But in that case, then you said if it could pick up both, is there capabilities within the same channel, within the same frequency, to actually draw out both? I guess that's the piece that I don't understand.
I believe not. I believe that's if you're in the same channel at the same time, then yeah, well,
Okay.
It's like two people speaking through each other. Yeah, you cannot extract a lot from that.
Okay. And so I guess that so then is this technically, this is all half duplex, full duplex? I don't really. So full duplex would be two different channels, right? Like one send receive.
Full duplex would be like sending and receiving at the same time.
Oh, okay.
This is half duplex.
Okay.
In the case of only using LoRaWi, you can design your own application and pick the time you want to send or listen.
Mm-hmm.
In LoRaWAN, there's actually 3 different schemes for that.
Okay.
You have the Class A LoRaWAN, which is you send an uplink with your device, and then you should listen for 2 downlink slots.
Okay.
One is immediately after your uplink, and one is a little bit later.
Okay. And that helps to take care of distances, or how does that work?
That is for the situations where you mainly want to put data up to the cloud, mm-hmm. and when we already are awake, we also can do some downlink while we're at it.
Okay.
Class B is more for devices that can also be controlled from the network,
mm-hmm.
say like a street lighting.
Okay.
And they have scheduled receive windows.
Okay.
And Class C is even better for street lighting because you are always listening except for when you're transmitting.
Oh, is that higher power then?
Yes, but it's a street lamp, so it has like line power.
Oh, okay, yeah, interesting. And when you say so, always listening except for transmitting, so that is the same frequency and channel though?
Not necessarily.
Okay.
I don't actually know. I could imagine that when you send to the tower on one channel, you will get an answer on the same channel, okay. Because the nodes can only listen to one channel at the same time.
Okay. All right. Yep. But so I guess the thing that helps with that is that the traffic that's going out is addressed to a certain MAC address. Is that what helps to allow people to understand which message is intended for which device?
LoRaWi doesn't actually specify anything about that. Uh-huh. With LoRaWAN, you need to actually attach to a network.
Oh, okay. So it'd be like you do like a handshake, like, "Hi, my name's Chris. I'm talking to your network," and then when the packet's getting sent back, it's being sent for Chris. Is that the idea?
Yeah, exactly.
Okay.
It's LoRa is AES encrypted, so
Okay.
only the network that the message is meant for can decode it.
Okay. I was
There,
gonna that was on my list too. That's good to know.
yeah,
Okay.
there are two different ways to attach to a network. One way is to do over-the-air activation.
Uh-huh.
When you have a device, you put a secret application key in it, and
Okay.
the application key determines that the device belongs to a certain group of devices and connects to a certain application in the backend.
Okay, so that's like a unique ID of some type. Yeah.
Yes.
Okay.
And it's the key is shared between the device and the backend.
Okay.
And then the device does a join request, and it sends a message to the gateway. The gateway sends it to the network server, and then your own application has to allow the device to the network by generating keys.
Okay.
And then you'll get some session keys, and you're set up to go.
Okay.
The other way is to directly put in the network session keys. But that's not a recommended way, but it's really easy to test with because you don't have any handshaking. And
So it'd be like, so I have a little plastic widget. I upload the session key into that in like
Yes.
into memory or something, and then it just knows how. It's the key to the lock. Is that the idea?
Yes, it is true. And there are two different keys. One is to encode the network messages, and one key is to encode your payload data.
And why are they different?
I believe for example, when you have a provider that provides your network, you may not want to have them read your message.
Oh, yeah, that makes
So
sense.
they only have the network key,
Right,
and
right.
you only have the application key.
Okay, cool. Yeah, that's good. That's good to know. And so you said over the air is kind of it's the normal way to do it.
Yeah, that's a normal way to do it. That's the only scalable way because that way you can keep your firmware package the same for multiple devices because you need a different session key for every device.
Yeah. Yeah. I guess so. Yeah. Oh, I guess yeah. If the network's also defining it too, I was gonna say you could append like a unique ID on the device, like the Mac of the chip, or like unique ID built into a microcontroller, but you can't do that because the session key is generated from the network.
Yeah, and also the session you want to replace the session keys every session, of course.
Oh, really? Okay. So
Because otherwise you can slowly decode the key via all kinds of security things I don't really know much about.
right. Okay, that makes sense. Yep. Huh. All right. Well, that's good. So session key direct session key stuff is kind of like you said, troubleshooting and early programming, but then
Yes.
Otherwise it does it all on its own.
Yes. Well, the one other reason to use the direct session keys, which is called ABP, authentication by personalization, I believe,
Okay.
is when you are not sure the gateway can send a message back to you.
Oh. Because of distance or what?
Yeah, well, the systems are not symmetric. So you have a transmitting device that is largely different from the receiving device. And gateways are a lot more sensitive in receiving than devices. So when you're in the edge of the network, you don't have really good coverage. You can send a message to the gateway because it has a high sensitivity. But if the gateway sends something back to you, then you cannot hear it because you're not sensitive enough.
Huh. Okay. So what does that all look like? So as you're moving towards getting a device on a network, what does that look like? Is it just like you talk to the gateway and then it says nothing back to you?
The gateway is actually a very passive device. There are two more components that are behind the gateway.
Okay.
You have a network server and an application server.
Okay.
And the network server shuffles stuff around. And the application server is the other end of your connection, essentially, where you manage your devices and where the data comes out.
Okay. And that's how it actually hits the
cloud
or whatever, wherever your endpoint is?
Yes.
Okay.
And you can write your own application server, and you can even write your own network server. It's all explained on the internet how to do that.
All right, go internet. Okay, so maybe let's take it back to you in terms of hardware person. How much of this stuff do you actually have to do? Like, how much is taken care of on when you're getting new devices online and everything?
Yeah, well, you can order the Semtech chips directly. Mm-hmm. Or you can choose a module from other companies, like, for example, Microchip. Mm-hmm. If you want to have a short time to market, you, of course, choose the module. Also, if you want to have a little bit more easy development, you choose a module. Mm-hmm. But if you really are scaling a lot and are implementing a lot of devices, then it's, of course, cheaper to do the chips directly.
Sure. Yep.
If you use a module, then everything is really simple. Most modules use an AT command interface.
Oh, really?
Which is it's really simple for all the steps you need to do connected to the network. It's like 3 or 4 commands you have to send in sequence, and then you're connected to the network.
Okay. So I'm like halfway through an Adafruit tutorial using the RFM95.
Yes.
And that actually has a library from the Radiohead library, it's called, and that I think someone else wrote. But basically, so I'm talking through layer and layer and layer. But I guess the thing I haven't actually looked under the hood of that library, but I'm guessing that's probably taking the stuff and doing all the AT commands and the handling of things, right?
Exactly. There's just an AT command handler.
Okay. Interesting. AT command, that's obviously that's a big thing in cellular. I'm kind of learning about that too, and those things are never going away, are they?
No, it's pretty old. I believe it's like 80s or something.
Yeah, I mean, that's what Nokia phones and stuff used too, I think. So I know it's like network standard interface type stuff, but boy, it's sticking around.
Yeah, but it's really working very well. As long as we're still using serial connections, then why wouldn't we use the protocols that are working on top of it?
Sure. And so are you kind of do you have software people in house that are helping you write kind of user libraries that you can not have to touch the AT commands, or are you regularly just writing AT commands for these things?
We as a company actually made the hardware that is being sold by the Things Network.
Oh, great.
And they also have an TTN Uno, which is just an Arduino with a LoRa modem on it, and an excellent library for Arduino. So I always use that because we have lots of them around the office. And
sure, right, yeah.
The best support I can get, I guess.
That's right. No, that's the way to do it. That's smart. Okay, cool. Things Network is one of the gateway. It's like community-based gateways. Is that right? Or
yeah, it's really the network of the people.
Okay.
So there are people.
Yes, comrade.
Yes. There are people that own a gateway and that's connected to the backend from the Things Network. And that way they share their gateway in a common network. So there are other people that have devices and they can register themselves on the network, on the Things Network. And then whenever they come close to someone that has a TTN gateway or a gateway that sends signal to the TTN backend, then you're connected.
That's great. So I'll have to look back to my notes now. So the over-the-air activation then is taken care of. Or wait, so the network server and the application server is what you were talking about on those gateways, right? So does that mean that when you sign up for the Things Network, that the network server is taken over by the Things Network? Is that right?
Yes, that's true.
Okay, cool.
And also part of the application server, if you want to. Okay.
So basically, it's like borrowing someone else's firmware, but then you get more networking because of that.
Well, it's really hard to build your own network because you really need to own a lot of land or a lot of interesting places to put the gateways. So it's really great if you can share it. If you deploy a few gateways and share it with other people, then that's the only way to get a truly really global network that you can use for free, I guess.
Yeah, no, that's great. And so what? So it'd be like I'm setting up a small gateway in my house, I have a bunch of sensors in my house. I have a gateway. I sign up on this thing, and then it also offers it to my neighbors. Is that kind of the idea?
Yes, if if your neighbors have sensors, then they can connect to the network via your gateway.
Mm-hmm.
But also, if you take your sensors with you in your car and you go to another city, then you can use their network.
Okay. So then how do the sensors then set up with the network? How does that work?
Well, all the gateways are just pass-through devices. So you are always connecting to the same thing, essentially.
Okay. So, okay, I guess, does that mean that so I don't actually have to be a member of the Things Network as a node, right? So if I have a temperature sensor and I'm driving in my car from Chicago to Cleveland, and there's a couple networks along the way, basically it's like an open enough thing where it will just find the next tower and send it through that to my endpoint on like a AWS IoT cloud or something.
Yeah, exactly. That's the case. You don't have to have a gateway to use the Things Network.
Interesting.
There's also a really fun activity with which you can help the network without having a gateway, which is war driving.
War driving. Okay. What is that?
Well, you just take a node that's constantly sending out, or as much as you're allowed to, sending out a message.
Uh-huh.
And when it gets received, you can track down which gateway it was. Because not all gateways are visible to the network, and not all their locations are disclosed. So if you are driving past it, you know it was there. It's just like the Wi-Fi war driving.
Okay. I didn't know that's the thing, actually. So war driving is basically just discovering new networks?
Yes.
Interesting.
Google did this on the Street View cars.
I was going to say, I did learn that Google has a reverse API lookup so that if you see a new network and that it has a unique ID, they can tell you pretty much. That's also how they figure out where you, like when you click on your phone, use my Wi-Fi to help locate me faster for like GPS location. What it actually is doing is looking up which Wi-Fi networks it sees and says, oh, you're probably here.
Yes.
That's creepy. But that's the effect of, that's the result of war driving, you're saying, and having lots of devices on a network.
Yeah. And also the network is pretty fluid for the Things Network, because people just unplug their gateway, and so to keep the data up to date, war driving is the only really true reliable way to know. Interesting.
And so if someone wanted to participate in that's listening right now, what would they do? They'd buy a node, set up a node, and just start connecting randomly with packets?
The most famous, or the most used tracker is ttnmapper.org.
Okay.
It has some pages of how to set up your LoRa node to work with the mapper.
Okay.
You only need the device, a TTN account, and the code that is provided by TTN Mapper.
Okay. And then it's just basically so it's sending to some endpoint as well, I'm guessing.
Yeah.
Their endpoint.
You can send location data via LoRa, or you can actually use an app that you send the phone's location to the backend.
Okay. Yeah.
And that way you don't have to have a GPS LoRa enabled thing.
Right. Okay. So it's probably just sending GPS coordinates, strength of the signal, name of the signal, and whatever else it sees, right?
Yes.
Oh, interesting. Okay, so let's get back to the physical side of this stuff too. So you had talked about spreading factor, but how does it? I mean, so okay, now I see there's a tower 10 kilometers away within the line of sight effectively, but then I start moving away from it, and the signal gets worse and worse. Does the module actually change itself, or what actually needs to happen when you do start getting weaker and weaker signals?
It could actually change some parameters. That's called adaptive data rate.
Okay.
But there are a few knobs you can turn to get more range.
Okay.
One of them is the spreading factor. And spreading factor essentially is the duration of the chirp.
Okay.
So instead of going from low to high in a really short time, it goes low to high in a longer time. That way you can increase the energy per symbol, so the energy per bit, And you can imagine if people talk slower, you can understand them better.
Yes, this is how I get around foreign countries.
Yes.
Just speak English really slow.
Yeah. Increase your spreading factor.
Right, and louder too. I try and get louder.
Yeah, but
Do you understand me? Sorry.
louder is sadly not allowed. You are mostly sending at the maximum transmission power.
Okay. All right.
You can lower it, but then you're really close probably.
Okay. And so that makes sense. It's a trade-off of battery power. So if you're already sending it max power per signal or per chirp, then spreading out the chirp just means you're adding more battery current going through going through your chip, going through the antenna, which creates invisible wavy things, which then wave for longer.
Exactly.
Okay. All right.
There's another thing, and that's the coding rates. Because your actual data is encoded with a pseudo-random stream,
okay,
which is some mathy deal to increase the amount of signal you can get out of it from the end.
Yeah. Okay.
So you can add more pseudo-random data to it, which makes the messages longer.
Yep.
But then it's easier to get the data out. It's similar to the technique the QR codes use to get data out.
Yeah, I saw Mike Osman giving a talk about this at DEF CON, and it blew my mind a little bit that it's like, yeah, you just add a longer string, and I guess it's just I guess the thing I don't understand about it is you don't need to know the string on the other side, right? Or you do need to?
I believe it's a pseudo-random string, so I guess, I don't know, actually. No,
yeah, I'm trying to remember the presentation, too. I remember, so Mike was talking about going from, 512 bits to, 2048 or something like that. It was a significant change in terms of the number of encoding bits.
Yes.
But I didn't understand... I honestly, at this point, I've just forgotten. That was back in August, so... Yeah. But that's interesting. Okay, so it's basically, Joe, it's just more encoding bits that allows you to draw more crap out of the draw more signal out of the crap of the noisy environment that you're in.
Yeah. Yes.
Okay. And so the trade-off here in both cases is pretty much just battery. Is that kind of the main thing?
The trade-off is always between battery and range.
Okay.
And yes.
So if you want a really low battery power situation, you probably want to just set up another gateway.
You can set up another gateway or move to another technology. If you're really close, then you're best off using BLE, which is
sure. Yep.
orders of magnitude more low power than LoRa.
Okay. Yeah. So maybe that's a good segue into what is the applications that you've seen so far. What are the usual battery lives, capacities and battery lives that you expect to see? Excuse me. I always, the measure is always I can do a year on a coin cell. It's like, okay, well, but what does it take?
Coin cell would be a little bit too little in amperage wise in immediate power.
Sure. Oh, you mean just because of internal resistance and stuff?
Yes, exactly.
Got it. Yep.
But if you have a few penlight cells, then you have enough. We usually use lithium chloride cells, and then you can get really, really long lifetimes of 10 years.
Oh, really? Okay. Of what kind of capacities?
There's some. It really depends on the application and the sensors, of course.
I guess, yeah.
But we have some amazing batteries that are, if I'm not mistaken, 11 amp hours.
Okay.
Which is pretty huge.
Yeah, that is pretty big. But again, that would sit there and transmit for a good chunk of time. That would be one. Yeah. So that'd be like a street light backup or something again where it's sizable. You can add extra stuff in there, right?
Exactly. Yes.
Yeah.
But you can easily get, I believe, a year or 2 years. It really depends on the application. But a year or 2 years is not unheard of on two AA cells.
Well, that is amazing. And that's and that's also you also play with the amount of data you're sending, right? If it's just a little bit of data, if you're updating once a day or once an hour, it's probably not that much data, right?
Exactly. Well, once a day and once an hour just makes also a world of difference.
That's true. Yep.
But usually what you do is send periodically a keep alive message, and then send some other data when it's relevant. So if you are measuring temperature, only send it if it actually changed.
Oh, interesting. Okay, and so then the that's kind of more on the cloud side of actually storing that it's still there, it's still transmitting, but nothing else has changed. So just keep the same flat line on your graph.
Exactly.
Yeah, that makes sense. And then so is that because a keep alive packet is really tiny?
Yes, you can make it really tiny, so it's really low power. You can also put a tiny bit of data in it. Maybe just send the temperature once a day, and to increase resolution, send when it's relevant.
Okay.
But you generally want to know every day if your device is still functioning.
Sure. Yeah, definitely. Right. I mean, that is kind of the thing where it's like, oh, if you didn't do that keep alive, you're like, oh, it's fine. And then a year later, you're like, oh, it actually has just not been active, right?
Yeah. Which is really bad if something is getting underwater or something.
Right. Yeah, that would be bad. So what about on the? I know you're on the hardware side, but like in the stuff you've seen, at least, is it usually using like MQTT, or what kind of like protocols is it actually talking over? Is it just? I guess I don't even understand. Is it just a packet of?
Yeah, it's just a packet. So LoRa has its own message format and headers. Usually on the side of the cloud where it comes out the other end, it is often it goes into a database, or it goes via MQTT.
Okay, that sounds good. And I guess an MQTT server, then you could just use that. If it goes into the MQTT server, then the idea of that is that it's also broadcasting it back out to whoever subscribed for it, right?
Yes.
So now I'm on a Wi-Fi network. The MQTT server's on the Wi-Fi network. It received a packet. It's stored in the database, and now it's like I'm subscribed to what is that field device number 4. It'll just kind of relay that to me.
Yes.
Interesting. So I'm still a little confused on the gateway piece, though, right? So so you said you saw these other gateways, right? So you said you saw Antwerp, you saw Utrecht, and then you had your local one, but on your RC plane. But like, does it send it through all of them, and then it's taken care of on the back end? How does it actually know who actually stores that data then or sends forwards the data along to your endpoint? Okay,
so the message is received by all the gateways in range.
Okay.
And all the gateways send their data back to the same network server. Okay. And the network server actually takes care of double receivings and selects the best gateway to send a message back if you want to.
Oh, interesting. Okay. So that is one of the big roles of the network server, like you're saying.
Yes.
Okay. And then, And so the network server, though, is actually like on a cloud device? Is that the idea?
Yeah. It's also you can put it on your gateway, but that's for testing. It's great, but in any serious application, you want it in the cloud.
Right, because then you'd also have to talk back through all the cloud infrastructure if you had multiple gateways, right? If you had it on your gateway.
Yes. If you have multiple gateways, then it's no question you should put it somewhere central.
Okay.
You also need quite a bit of horsepower if you want to send. If you, for example, use Class A. And want to send something back to the node after it has sent something to you, you have a couple of, I believe, tens of milliseconds to process what it has sent, think of something to send back, and then get it to the device before it goes to sleep again.
Okay. And then you said in Class A, you said there's listening for 2 slots, one that's right after the uplink, and then the one that's later. How does it know when to wake back up? Is it like a defined time?
Yeah, that's a defined time.
Okay. And is that settable as well, or is that something that's just like it's always 40 seconds later?
I believe it's fixed. I don't actually know the number. Okay.
All right. Well, so maybe a better question is, how often are you using each of these, A, B, or C? Like, is it? I mean, it sounds like it's application dependent, but what have you seen most?
By far, the most is Class A.
Okay.
And also by far the most, it's only uplink.
Oh, okay. So it's just transmitting temperature, and then you don't send anything back.
Yeah, there's very little use cases where the device would do something that is controlled from the network.
Okay. Yeah, I was gonna, because that was my next question too. Is like, when you do need to send something back, which one do you usually choose? Do you choose right after, or you choose the second slot?
Usually, if it has to go through your application, you are already too late for the first slot.
Okay.
The first slot is for data that you already put in a queue.
Oh, okay. Okay. So it's like you schedule like a shutdown for the night or some kind of command set that happens right after. That's kind of the idea.
Yeah, for example, or like settings change. That's one use case to use downlink is. For example, you don't want the device to send every day, but every hour, because the situation changed. And then you say, hey, send it every hour to me instead of every day.
Yeah.
And that's an ideal thing to put in the first downlink message.
So what about like, so in these situations where it's Class A or even the other, like Class B or C, is it possible to update firmware over this, or is that just way too much stuff?
No, that's not an option. I don't know if it's on the roadmap, but currently that's not an option.
Okay.
All LoRa devices also speak FSK.
Okay.
Which enables far better bandwidth. But it comes with
I don't know what that is actually. Sorry.
Frequency shift keying.
Okay.
And it's a more basic kind of modulation, if you will. But you could do it over FSK, but I have never seen any case where that has been done.
So, but that would be, you'd have to be local to the device, just not plugged into it?
Yes.
Okay. Yeah, so I assume that one of the benefits of this is that you can make an enclosed, like a waterproof kind of, your battery's never going away. Well, you got a battery for a while, you're low power, you don't need much in that way. I assume that you could enclose this whole thing and just be like, when it's dead, we're throwing it out.
Yes.
Not that I approve of that, but yeah. But you're saying that FSK would allow to actually reprogram then without a USB cable.
Yeah, but I would recommend using Bluetooth Low Energy to do firmware update.
Okay, all right. So just some kind of wireless nearby type thing, but you're not going to do it from a gateway back down to the node at this point.
No, LoRa is not the right technology for such application.
Okay. Yeah. So what has been the best? I mean, you've seen a couple applications at this point. What has been like what type of application, not necessarily who or who's using it, but like what type of application has been like, oh, this is just tailor-made for it?
I think remote sensing is tailor-made for it. There are two different scenarios where LoRa really shines, and that is when there is no other network available, so you have to set one up anyway. And when you have a relatively large amount of sensors in a relatively tiny amount of space. So let's say you have like a container terminal in Rotterdam. We have a pretty big one. And,
like a shipping port, you mean? Like
yeah.
Okay.
And there are containers there that are on a train that is a few kilometers, square kilometers. So you can use only just one gateway, or maybe 3 if you want to get around some dead corners. To cover the whole place.
Yeah. Okay.
And then it would be really cheap.
Yeah.
But if you have an application that is over the whole country, you're traveling around, then you're maybe better off using another technology.
Yeah. That's a great point. And so like I was really surprised, like I've come into a internet connected type role now too, and my new thing is like, you're not going to get away with just one. Someone who says there's only one way to do a thing, or that there's only one thing that will solve all problems is lying through their teeth, right? Yeah. Because sometimes it's LoRa, sometimes it's, or similar type of thing. Sometimes Wi-Fi is the right call, sometimes Bluetooth, sometimes cellular, whatever. So yeah, it's, you got to, unfortunately you have to know all of them, but that's also kind of exciting, I suppose. And it seems like with the hardware that's out there, it's getting easier. Does that sound right or no?
Yeah, sure. You can use a multitude of technologies right from your home, ordering it from AliExpress or something. And I think it's really easy to implement these technologies today compared to what you have to do 10 years ago.
Yeah. Okay. That's good. So in your day-to-day, are you mostly focusing then more on the sensor side of things and the micro processing type stuff, or is how much of this is a hassle to you, or how much is it just kind of built in at this point?
Not very much. The main things I am working on is sensor technology, and sometimes converting an older sensor technology to one that is more low power. Because of the low power battery requirements. So yeah, for example, the MQ gas sensors are a very good example.
Okay.
It's very fun to hook them up to the Arduino and smell some CO2 or methane or something else. But there's a heater element inside those sensors. So it's out
right.
of the
Not great for low power, huh?
No, that's out of the question, and also has a heating time of 30 minutes or something ridiculous.
Whoa. Okay. So what are you like doing pulses, or how you have to actually change it around then, or what are you doing there?
What I am usually working on is finding other sensor solutions from manufacturers, or sometimes even rolling our own.
Oh, cool. That's neat. Yeah. How much of it is? Are you seeing a lot of projects that are kind of building this stuff with small solar panels as well, or does that make sense for a lot of these cases here?
Yeah, we actually have a thing here called Trist, and that's a light energy module.
Okay.
And essentially what it is a little brick, and it has a solar panel on it that is really efficient indoors.
Oh, wow. Okay.
So it has an efficiency optimum that is around the light level that you have in a business building. And you can use them indoor to power your sensor.
That sounds like and if so, you've got a low power sensor, you've got with indoor lighting. That's pretty impressive, actually. What kind of output does it get?
Power outputs. I think it has a peak. I don't actually know.
I guess it's probably charging a battery though, right? So it doesn't matter.
It's charging a buffer, and it's working from 200 lux.
Wow. Okay. Yeah, that's pretty low. Yeah, that's great. I've seen those. A lot of the what do they call them? Like microchargers or something like that. Like where they kind of sip off of solar cells and stuff like that. They have really, really low drop diodes that kind of help with boost circuits. So
Exactly.
Really interesting stuff.
So a LoRa message takes in the order of tens of milliamps, and if you have some kind of buffer, you can use this module to send LoRa messages.
Okay, that's good. Yeah, that's good. That's good to know. So then, the only real restriction would be how long it takes to refill that buffer, right?
Yes.
Okay.
Yeah, that's true. And it will be quicker when there's a lot more light, and it will be slower when there's little light.
Right. But that's a great capacity thing. Is that one of the things that you can go and so say you were in class A and you had a downlink slot, could you tell it to stop sending so much data because because of a change in the power capabilities, or?
Well, it would be smarter to do that locally.
Okay.
So what we sometimes try to do is make the sending scheme dependent on the energy that is available.
Okay, so you do like a current sensor in line, and you say, well, I only have, or is it like you can talk to that power brick type thing?
You cannot you can talk to it. You can measure how full it is in voltage, and then you can say, okay, I've got about this much energy left, so I'm going to send this often.
Okay, all right, and then would you sometimes then encode like how often you're going to be sending with that one message then as well?
You could, but that's a trade-off. It also costs extra time to send actually that data. You want to keep it actually as short as possible. Interesting.
So you do that as well. So you optimize the packet length to only send exactly what you need.
Yes, and the smart things to do is for example, GPS location is just send the full location once, and then from that send a relative location.
Oh, interesting. Okay.
So if your device is not moving all over the world really fast, then it's really feasible, and it saves a lot of data.
And then does that also pair it with the, don't send it unless it actually is changing, or you just send, when you say relative, then is it because there's fewer digits of precision needed?
Yeah, but there is the same kind of precision, but why would you send? Why would you define where you are on world scale when you never move more than a few kilometers a day or something?
Right. I'm just thinking about like so it's usually like 49.42466 or something like that, right? But then you'd only be sending a 0.0006 or something.
Yes.
Wouldn't that be it? So I'm just thinking like, depending on how you format that number, it could be the same length if it uses this, like if it was like a float or something, you'd still send the same number of bits though, wouldn't you? Or
But
is it?
if you multiply it by like 1,000, then it becomes a lot of smaller number.
Oh, okay. Interesting. Yeah,
You have to keep the track on by that with that in the backend to divide it by 1,000 again.
Got it. Okay. Yeah, so are there any other compression techniques that you then implement in this case, or is it more of it's a customized enough message that it doesn't need some compression?
We don't have a standard way to compress data, but there's a lot of these tricks you can do to make the data as small as possible.
Yeah, that's great. That's a good one. I mean, okay, that's really interesting. And maybe give us an idea. We're over an hour here, and I could probably keep going for a little while. But how much of this is? How much standardization is there at all? Even for like within your company, project to project, is it always custom because of these power needs?
Yeah, it's mostly custom with our projects. There are actually some standards that are defined by some LoRa backends.
Okay.
So there are some companies that deploy a network server and application server, and they also define a way to structure your messages. And some people standardize on it, and some people don't. But we usually have the really hard cases where we're right on the edge of the possibilities. So we have to use techniques to reduce it.
Yep. Yeah. No, I know that goes. Like I have a friend that does Bluetooth standard stuff, and sometimes the Bluetooth ain't so standard. Like if if you're right on the edge, sometimes you got to just like, well, you're not going to work with everything, of course, but your devices that are talking to each other probably will, because they understand those variations and all that other stuff. So it's just about defining both ends. I'm trying to figure out if I have a clear picture on. This has been, first off, very, very useful. And I will be posting all of these pictures you sent me, which were very useful, and links and stuff. I'm still I may have asked this already, but if there's a device. So there's a node in the field. I make a node. You're running a gateway. Are you saying that I can just connect to any gateway that's LoRa based?
It's not really a connection. It's really a connectionless thing, LoRa. Okay. So certainly, if you send a message which is broadcasted to everyone, then I can receive it with my gateway, and my gateway would send it to my network. And my network would have a couple of keys for its applications, and it would see with which key it can decode the message. Okay. If it cannot decode the message with my keys because you are not on my network, then I don't have anything to do with the data.
Lost in the ether, right? Yeah, I get that. It's thrown away. But I guess I'm kind of thinking about it like Wi-Fi at this point, but maybe that's not a good example. But like, I can see other people's gateways now. So I have a node. My node sees your gateway. It has to be actually authenticated at some point.
No, it's connectionless. So it's broadcast every time, and then everybody forgets everybody. Oh. So there is a session in the sense of the session keys and the security, but the gateway is fully passive in that sense, that it doesn't know which nodes are talking to it and to which nodes it is talking to. And only the network, the backend, knows its nodes and knows who it's talking to.
So, all right, that might be getting a little too software-y for me. Maybe this is where this is falling apart in my mind. But yeah, okay. So the gateways are front ends with a backhaul to a network server, and then that's where all the magic happens. But the gateways are there to enable this on the RF side, right? So it's internet to LoRa packet thingy.
Exactly. It's not quite SDR yet, but it's they don't do really much more than an SDR would do.
Mm. Yeah. Okay. That makes sense. What about so from a security perspective, it sounds like I know you said you're not a security person, but you've at least thought through some of this stuff though. So wouldn't it be possible that some rogue person could come and flood a gateway with a bunch of bad traffic?
If it like jamming,
I guess so. I guess you could do that on a Wi-Fi. I mean, you could do that on authenticated networks too, so that's not a big deal, right?
With Wi-Fi, you have some certain attacks that work this way, where you have a de-authentication attack.
Sure. Yep.
So you send to the access point I am de-authenticated, and you impersonate some other device.
Yeah. Yep.
And you send to the device the network has disconnected from you, and then they both think they are disconnected. Yeah. That's some kind of attack you could not do with LoRa because there is no connected or disconnected state.
Huh. So the only thing you could really do is jam, like you said, because you're not interrupting someone's point A to point B connection with a key. You're just flooding the receiver with too much stuff, right?
Yes.
Okay.
You could do that. You could do that with LoRa specific packets or with just random noise.
Yeah, the spark gap.
Yes, of course. Yeah.
Okay. Well, I think I get it. I'm sure that if people don't get it, they will leave comments in our comment section or maybe on our Reddit. But Richard, this has been a great. Thanks for explaining all this stuff to me. It sounds like you've got quite a handle on it, and you're working on some interesting things. So, where can people find out more about you or your company or anything else going on in your life?
You could go to our company's website.
Sure.
Which is twtg.io.
All right.
If you live around the Netherlands or in the Netherlands and you want to work here, that's also possible.
Oh, nice. Okay.
If you want to contact me directly, I can leave an email address in the comments or something.
Right, and we were talking about before the show. You have a Twitter account, but it's somewhat silent.
Yeah.
Are you? Well, you said you're a big Hackaday fan, though. Maybe are you on the Hackaday IO? Maybe people could reach you there.
I am on the Hackaday.io. I have a few projects there. Also, I haven't been there for a while. So,
okay. All right. Well, we'll link your profile there as well because there's a chat thing in the back end. But we'll also have the email address.
Yes.
Okay. Well, thanks so much. I appreciate hearing all about this stuff, and I'm going to be looking into it more. I do have some modules on my desk, and I promise they'll be working soon. I'll have more questions for you too.
Okay.
All right. Thanks again.
Great. Bye.